Yeah.
So 150 divided by 500.
Oh, that side. Okay, 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 okay.
Or you can simply think, you can simply do probability doctor and loan divided by probability of loan. Correct?
Uh-huh.
So
Yeah, yeah, I
doctor
get
and loan, it will be 150 divided by what is the total? This all total. I think it's a 500. So 1 second. So in this question, what is the total number of person? 150, 300. They are okay. There are 2000 in total,
Yeah,
correct?
total to 2000, yes.
Okay. So
Yeah,
I can do 150 divided by 2000,
I did that,
correct?
sir. Yeah.
And how many persons are defaulted for loan? 500. What is
500,
the
yeah,
probability
total
for
500,
loan?
yeah.
So
Oh, so
500 divided
500 by 2000. Okay, okay, okay. I did
by,
that wrong. Okay.
so 2000 will be cancelled out. You will get at the end 150 divided by 5.
Okay, 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 okay. Now we are
Or,
getting, okay, now we are getting
or you
point.
can direct, you can do the direct like yeah, it is given that he is defaulted in loan. So what is the probability that that is a doctor? So 150 divided by 500 direct thing.
Okay, so the row relative we are taking in this case. Okay, got it, sir.
Yes,
I
yes,
mean,
yes.
we are
Yeah,
taking.
according to the statement of the question, you have to think. Okay.
Okay, okay, sir. Got it, got it, got it. Thank you.
Yeah, so basically, this is open session for weekend. So we can go lecture wise and activity wise. So if you have doubts, so we can, I mean, you can ask and we can discuss. Okay. So any one of your doubt in
Excuse me,
this lecture 8.1 or in activity 8.1?
excuse me, sir.
Yes, yes, please.
Sir, I have doubt related to some formulas, sir.
Related to concept.
Yes, sir.
Okay. What?
Sir, the formula you recently used, the condition probability formula
Mm-hmm.
and the Bayes law formula. Sir, I am confused between the two.
Yeah, base is the different thing. I mean, see, base is also type of conditional probability. But in the conditional probability, you have to do a simple thing. Suppose I have event A, correct? And I have event
Yes,
B.
sir.
Suppose I'm saying what is the probability of event A when B is given? Means B
Yes,
has occurred, then what is the probability that A will be probability of occurring of event A? So it's nothing but probability of A intersection B divided by probability of B. That's all.
P.
Okay. Like you can
Yes, sir.
understand by Venn diagram. Suppose this is my sample space. This is my A. This is my B. Correct. This is B. This is A. So I'm saying
Yes, sir.
my A given, I mean, event B is, it is given that B has occurred, right? So B is
Yes.
occurred. That means this green region has been occurred,
Yes, sir.
correct? So my new sample space is this B region. I'm interested in this B, in this green region. It is saying that B has been already occurred. I mean, my new sample space is here, this green region,
Yes,
correct? Then what is the
yes.
probability of occurring of A when B has been occurred? This red region.
Yes, sir.
Are you getting? Probability of occurring
Yes,
of
sir.
A when B has been occurred is this red region. Okay, that is what is
Yes.
nothing but probability of red region is what A intersection B,
Should
and
be.
green region is what probability of B. That's it. Okay.
Answer Bayes law.
Yeah, I will come to base theorem. First, I am going to each, I mean, each lecture wise. Okay.
Okay.
Yeah. So in activity 1 point, I mean 8.1, any one of you any doubt? This is nothing but the contingency, I mean, you can say kind of contingency table. Here you have to find the probability. So any one of you have any doubt in the first question or second? Hello?
Yes, sir, you are audible, sir.
Yeah, so I'm asking any one of you have doubt related to week, I mean, activity 8.1?
Yes, sir. I had that problem actually, so you solved it.
Okay, okay. So, is this clear for everyone? Then I will move to next activity. Because these all things are just based on this table, okay? Like what is the probability that selected person is a teacher? So selected person is how many teachers are there total? 1200, correct? So 1200 divided by 2000. Am I right?
Yes, sir.
Okay. So similarly, what is the probability that person has defaulted in loan? So we have to consider the
The row
row
relative, the
to
500.
yeah, row total of the yes column. I mean yes row. Okay. So similarly, we have to consider the three question number 4. Question number 4 we it's nothing but it is asking about conditional probability that person has defaulted in loan given that person is a safe. Okay. So it is given that person is a safe. That means how many safe are there total? 250.
50.
What is the probability that that person defaulted in loan? So 50 divided by
250.
so similarly we have to proceed. Is this clear for everyone? Any doubt in this activity?
Sir, I have a doubt. Like it's sometimes confusing when to take the row relative and when to take the column.
That's why Pooja. Thing is that you have to read the statement carefully. It, I mean, don't like, no, it is not like you have to memorize. Yeah, it's a row relative, it's a column relative. No, you have to be careful. Like in the fourth question, what is saying? If you are getting confused, so just write the formula. What is the thing is given to us? What is the conditional probability that person has defaulted in loan, given that person is a safe, correct? So what's given to us? Person is just safe. So person is just safe. That means how many safe is there?
250.
So what we are doing here? Column. Forget about column relative frequency, row relative frequency. Just do simple probability. How many safe are there? 250.
250.
What is the probability that the person is defaulted in loan?
Or 50 by 2.
That's all. No need to worry about row relative frequency, column relative frequency. Okay. If you are getting still confusion, just write the formula, right? Probability that defaulted in loan, I'm writing L for loan, given that person is safe, right? I can write like this. Okay. So similarly,
Yes.
I can apply the probability that I can apply the conditional probability formula, loan and safe divided by probability of safe. So what is the now? What is the probability that uh, person is defaulted in loan and he is safe? So 50 divided by 2000 in total, correct?
Yes, sir.
And what is the probability that person is defaulted and person is safe? How many
250.
safe are there? 250.
250.
So
Yes.
250 divided by 2000. So your 2000 will get cancelled out. So in a way, at the final step, you will get these things. Like these things I have explained. Okay, B has occurred. It is given that. It is given that event B has been occurred already. That means my new sample space is the green region. So what is the probability that event A will occur when B has been already occurred? So this red region, I mean this red region will be for A when B has been occurred. Okay.
Yes.
So what is this red region? Is nothing but A intersection B and your total case. That's all.
Okay. Thank you,
Yeah.
sir.
So we can move for the next. Okay. So any one of you have doubt in lecture 8.2 or activity 8.2?
Sir, the fourth question.
Please mute all. Okay. Okay. So in the first question, any one of you have any doubt? Hello.
No, sir.
No, sir. No, sir.
It's clear for everyone?
Yes, sir. It is clear.
Okay. So you have to apply just the conditional probability things. Okay. And in the second question,
The second is pretty straightforward. It's just normal thing.
yes. If any one of you have doubts, so you can discuss. And what about third?
Sir, I haven't got the question 4 correct.
Yes, sir. I also.
Yes, sir, for me too. The fourth one, actually.
Okay, till third, it's clear for everyone. I'm assuming, right?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So what the fourth is given to us? What is saying? Two fair dice are rolled, correct? Okay. And what is the probability that at least one of the dice lands on 5, given that, okay, what is the answer for third one?
So it is 0.
0. It's a simple thing.
There is no
Conditional
intersection,
probability
sir.
that,
So
yeah, there, when you will apply the conditional probability formula, there will be intersection for an ace and face card. Okay. So if it's a face card, then it will not be ace, right? So direct 0. Okay. Yeah. So come to the fourth question. Two fair dice are rolled. What is the conditional probability that at least one of the dice lands on 5, given that their sum is 11? Okay. So let me insert a piece. Okay. So probability. Okay. I'm going to write as, so at least one dice on 5 lands on 5, correct? Given that sum is 11, we have to compute this probability, correct? Okay. So can I write probability at least one dice lands on 5 and I mean intersection sum is 11, correct? Divided by probability that sum is 11. So far it is good. Okay. Okay. So when you will roll die, I mean roll die, what statement? Yeah. When two fair dice will be rolled, how many outcomes we will get?
36.
36 in total. And what is the meaning of at least one dice lands on 5? 5 1, 5 2,
so the entire 5 column.
5 3,
And also
5 4,
5 4, 5 5,
5 6.
5 6. It can be 1 5, 2 5,
3 5.
3 5, 4 5, 5 5 we have, and 6 5,
6
right?
5. Yeah.
These are the total cases when these events will be happening. I mean, at least one dice lands on 5. So far it is clear. And for event sum is 11, only 5 6 and 6 5, correct? I mean, are you getting my point or not?
Yes, sir. Yes, sir.
Yes,
So
sir.
far,
Yes,
it's
sir.
clear, sir.
So what is the common for what is the intersection for when dice lands on 5 and sum is 11?
5 6 and
Two.
6 5.
5 6
5
and
6
6
and
5.
6
5 6
5
and 6
6 and
5.
6 5,
Yeah.
correct? These two, that means 2 by 36
Yes, sir.
Yes, sir.
Yes,
or
sir. Yes, sir.
simple things I can write probability of 5 6 comma 6 5, correct? Divide by
Yes, sir.
probability when you will get sum as 11,
5
5
6
6
and 6 5.
6 5.
Got it, sir.
So what it will be? 1.
Oh, yeah. 2 by 36, 2 by 36. Yeah.
2 by 36, 2 by 36.
1 minute, sir. I have a doubt in this. Sir,
Okay.
why we are taking probability sum is 11, 5 by 5 6 and 6 5? Why we are not taking other options? Because there are many other combinations, right? Like 1 minute. Oh no, sorry. Okay, two only.
Yeah,
Allowed
there are
two.
only two
Yes,
options
only two.
when you
Yes,
will get
yes.
sum as 11, right?
Yeah, correct. I don't know where I made a mistake, but because
Yeah.
my thought process was also the same, but okay, fine.
Okay.
Now I got it.
So it's clear for everyone?
Yes.
Yes, sir. Yes, sir.
Yes, sir.
So what is the answer? Answer is also, I think,
Answer is 1, sir.
1. Yeah, 1. Okay, it's correct. So we can move to the next. So anybody have doubt related to multiplication rule concept or in this activity 8.3? And what is the multiplication rule? So first of all, so I have event A and I have event B, right? So you know this conditional probability formula, correct? And sometimes probability of A intersection B, we can write probability of AB for simplicity. So this is nothing but, so probability of A intersection B equal to probability of A given B into probability of B. This is called something multiplication rule, and I can write the same thing as probability of B given A into probability of A. Okay, this is something called the multiplication. Okay. So any one of you have doubt related to any question? to this?
Sir,
Mhm.
sir, in the video, 8.3 video, I couldn't understand the deck of the cards of deck, the deck of cards. Yeah, deck of cards. That problem I couldn't understand. I watched 2-3 times, but I couldn't understand that. How it is like they are doing 1 minus
What
some.
the thing?
Yeah.
I
In the
think
last video, yeah.
Sir, the ace
Deck
thing,
of
sir.
cards.
The ace thing, I guess.
this one.
Yes, sir. This one also.
So it's not for clear for everyone.
I mean, sir, the
Not clear for me,
concept
sir.
that ma'am is using over there, let's say like 13 cards, she's saying 13 cards in one pile. And let's say in that pile we have any kind of spade. Let's not just categorize the spades for now. Let's say
Yes.
ace of hearts is there. So
Mhm.
ma'am is saying there might be like another chance of like she's just subtracting one card, which is ace. That is totally justifiable. But the thing is, she's saying 12 by 51, and then she's subtracting that from the total probability, which is 1. I mean, she's doing that consecutively for all the piles. That is kind of confusing. I mean,
Okay.
like, what's the point?
Okay, let me check that one. An ordinary deck of 52 playing cards is randomly divided into 4 piles of 13 cards each. Okay. Compute the probability that each pile has exactly one ace. Okay, so she has defined events. Even the ace of spades is in any one of the piles, so that is the sure events, right? If you have 52 cards, okay, and you have already divided 13 cards in each pile, so ma'am has defined an event even that is ace of spades in any one of the piles, so that is the sure event. It will definitely occur. This is clear or not for even?
Yes, sir.
Okay, see, I have divided the 52 cards by, I mean, it's 13, 13, 13, and then 13. So even will be, I mean, the ace of spades will be in any one of the piles. It's correct or not?
Yes, sir.
I mean, it will be. It's a sure event, right?
So, sir, the point is the sure event that we are taking that sure event for each pile. That's why we are doing that subtraction.
No, then again, see, one second. Let me write the things. Ma'am has defined even as what was that? Ace of spades in any one of the piles, right?
Yes, sir.
Ace of spades in any one of the piles, correct? Right. So suppose I had 4 piles, right? Let's say P1, P2, P3. Okay. So I have put 10, 13, 13, 13. So what is the statement? Ace of spades is in any one of the piles, right? So it's a sure. ace of spades will be in any, it can be in P1, it can be in P2, it can be in P3, it can be in P4. So probability of E1 is nothing but the, it's a sure event. Are you getting or not?
Yes, sir.
It's
Yes,
a
sir.
sure, it will definitely occur, right?
Yeah.
Yeah. So come to the event E2. So E2 ma'am has taken ace of spades and the ace of hearts are in different pile. Okay. E2 is nothing but ace of spades and ace of hearts in different piles. Okay. So now we have to think what we can do. See, we have 4 piles, right? So we can do like probability of E2 given E1. We can do or not?
Yes, sir. Since E1 has occurred, we can do that.
E1 has occurred.
Occurred.
Okay. So suppose I'm assuming like ace of spades. We can denote ace of spades like ace of spades is in the pile 1. Okay. For example, correct. So
Okay.
ace of spades and ace of hearts in different piles. So for ace of spades can be in this or in this. Are you getting?
Yes, sir.
According to the statement of the E2 event, it should be in different pile, right? Suppose ace of spades in the first pile, so it ace of hearts should be in either in second, in third, or in the fourth.
Yes, sir.
So what's the probability that for that? What should be the probability?
We are left with 39 places in pile 2, pile 3, and pile 4. And
Okay,
51 are cards are like we have. Then we can 39 by 51.
39 by
It should
51.
Sir, can you please explain this part again?
See,
Uh,
it is
yeah.
saying that even is
Because I
given.
couldn't
I mean,
understand why why we are subtracting 12 by, you know.
okay, forget about 12 by that one. Okay, I have
Okay.
not seen that one. Okay, can you tell me? Suppose even has occurred. Even has occurred means ace of spades. Suppose I am going to take in. Suppose it's in piles 1. Okay, ace of
Okay.
spades in pile 1. E2
Okay.
event is saying that ace of hearts, ace of spades, and ace of hearts in different piles. That means
Okay.
ace of hearts should be in any one of these three.
Yes.
It should be in different piles. So ace of hearts can be in any one of these three.
Yeah.
I have taken the piles, ace of spades in pile 1. So that means
Okay.
13 cards is already, you can say like, I do not have option for that, this pile 1. Okay.
Okay.
So
So
ace of
now
hearts will be in remaining this 13,
remaining
13,
3 piles. Yeah.
39
Yes.
divided by 51. Why
Okay.
51?
Yes.
Because
Yes.
one event ace of spades is already there.
Okay. Yeah. Get it.
Correct?
Yes.
Now, what is
This
the
way is much easier, sir. I mean,
Yeah.
according
Instead
this
of that
this way is
12 and
much
all.
easier, sir.
which one? This
Sir,
one.
the way
You
that
are
you just
telling.
described, I mean
Okay.
the
Yeah.
remaining and that way is much easier to understand.
Okay. So what is the E3? Ace of spades, heart, and diamonds are different uh, uh, piles. Okay. So I'm writing as AS for I mean, you know, AS,
So
ace
now
of
it should
spades.
be available in 26.
So ace of hearts, and ace of, what was that?
Diamond.
Ace of diamonds, sir.
Diamond. Okay. So ace of diamonds are in different. Correct.
Yes.
So what it will be for E3?
So
By
26
notation,
by 50.
E3, given that I have E2 and E1 has occurred, right? E2 and E1 has occurred, right? It's okay.
Yes, sir.
These two has occurred. So what about E3? So it's simply, what is the my total remaining cards?
26. Sorry, 50 and 26. Yeah.
50.
50,
Yeah.
50.
26
for
by
I'm,
50.
I'm talking about total cases. And
Okay.
two piles are, let's say P1 and P2 are booked for, I mean, ace of spades and ace of hearts. So I have only remaining two piles. That means 26 by 50. Correct?
Yes, sir.
I mean, for ace of heart, ace of diamond, I have only these two piles, right?
Yes, correct, sir.
It's correct. Now,
Yeah.
what's the last statement my match taken? All four aces are in different piles. Okay. So E4 is all four aces are in different piles. Hope you are able to understand my writing.
Yeah. Now E4
So,
condition,
yeah,
E2 intersection, E1 intersection,
because
E3.
E3, E2, and E1 has already
Okay.
occurred. So what it will
Yes.
be? Suppose these three piles is already, this is for spade, ace of spade, ace of hearts, and ace of diamonds. So I have only last piles is remaining. So I have
13.
13
13
place
by
divided by
49.
49. Why
49.
49?
The three
Because
cards are taken.
one, yeah, one for ace of diamond, and one for ace of heart, and one for ace of spade. So 52 minus 3, that means 49. So it's
This
clear
one
now?
is very easy now.
So
Otherwise, it was
this
very difficult.
explanation was hella easy.
Okay,
Yeah.
thanks.
So I found it from comments right at that video, like on YouTube.
Sorry, what you are saying? I mean, your voice was something breaking. Hello, Jivraj, what you are saying?
The comments below in
Your voice is breaking. Can you rejoin? Okay, so Jivraj, just try to rejoin. Huh? So in this activity 8.3, anyone of you have any doubt? Oh, in that question, you have to multiply all the probability, right? At the end, right? It's clear or not? You have to do 1 into this probability,
Yes, sir.
into this, into this.
Like all the probabilities.
Yeah, for the multiplication rule. Okay.
Yes, sir.
Yeah. Yeah. So any doubt in this activity
Yes, sir. I
8.3?
couldn't get the answer. Question number 2 correct.
Question
Rest
number
I got
2.
correct. Question
These
number 2 I
card
couldn't get
problems
correct.
are, sir, so annoying sometimes.
Okay,
Maybe
okay.
I'll
So
try again. Yeah.
yeah. So suppose you take two cards from a standard pack of 52 cards, one after the other, without replacing the first card. Okay. What is the probability that first card is the ace of club and the second card is a diamond? Okay. So I'm doing like, I can define event E1 as ace of club, correct? Second is second card is diamond.
Yes, sir.
Second card is diamond. We can write it as a first is ace of club. Okay. So question is, what is the probability that first card is a ace of club and second card is a diamond? Correct. So what I can do, I can write probability of E1 into probability of E2 given E1 or not. Or I can write probability of, okay, first of tell me for this one. Probability of E1 is this first card is ace of club. So what's the probability for ace of club?
1 by 52.
4 by
1 by
1 by
52. And now, see, thing is that you can do this probability calculation without using this formula. I have written this formula just to clarify the things where you can use the multiplication. So here I can use the multiplication rule. Here even has occurred. It is given that uh, even has occurred. So even has occurred means I have already drawn the first card, which is ace of club. That means I have to consider the second card as a diamond out of 51 cards. It's clear?
Yes, sir.
Yes,
Okay,
sir.
sir.
So what is the probability of E2 when even has occurred? When even has been already done. So even has been already done means I have already drawn a first card. So I have remaining 51 cards. What's the probability that second card will be diamond? So diamond I have
13 cards, sir.
30.
it's clear for everyone.
Yes, sir.
Same thing you can apply like this formula, probability of E2 into probability of even given E2. Like here I have written. So you can do in opposite way. Like what is the E2? Second card is a diamond, correct? That means for diamond, I have 13
13
by
by
52,
52. Yeah.
correct? Then
Yeah.
what's the probability that diamond is there and I have draw a ace of club?
It's 1 by 51 then.
1 by 51. So this two quantity is the same thing. Okay, I mean you have to just do the calculation. I don't know about answer. So just do the calculation. It will be easy. 1 by I think it's
It's
204.
204. Okay, so you
Yes,
can
got
check.
it,
Yeah,
sir.
B option is the correct. It's clear.
Thank you, sir. Yeah, it's clear, sir.
Question number 3, sir.
Question number 3. Okay, consider that you have box 5 blue marbles, 3 red marbles, 4 yellow marbles. Okay, you are going to pull out one marble, record its colors, put him back in the put it back in the box, and draw another marble. That means I am doing the with replacement, right?
Yes.
What is the probability that pulling out a blue marble followed by a yellow marble? Okay, okay. So what is the meaning of followed by a yellow marble?
First yellow, then other.
First yellow,
Yellow
then
marble happened.
So the
Probability
yellow
of
event has
blue marble
occurred.
and then
so I can
probability of yellow.
define less even as how many marbles we are drawing? 2, right? I mean, what is the question? Pulling out a blue marble and followed by yellow marble. Okay, okay, okay. That means yellow marble should be drawn first. Okay, that means I can define my event even as first marble is yellow. I can define, right?
Yes, sir.
And E2 as a second marble is blue, correct? What is the probability that blue pulling out a blue marble followed by a yellow marble? Okay, that means E1 and E2. What is the probability that I can write or not?
Yes, sir. Multiplication rule.
Yes, sir.
From here you can interpret this E2 is followed by E1. I mean E1 is happened, E1 has been happened, then E2, correct?
Yes, sir.
What are 5 blue, 3 red, 4 yellow? Okay, so 5 blue is given, 3 red and 4 yellow is given to me. So what's the probability that first marble is yellow?
1 by 12.
1 by 12.
I mean, sir, total
4 by 12.
4
1 by
by 12,
13.
right?
4 by 12. 4, yeah.
Because
by
we
12.
have
We
4
have
yellow.
4 yellow marbles, yeah.
Okay, and what's the probability that second marble is blue?
It's 5 by 8.
5 by 12.
5 by
5 by
12. Why 12? Because in the question it has already written that we are going to pull out one marble, record its color and put it back in the box. Again we
The
have
replacement is allowed, so that's why.
replacement allowed. Again we have 12 marbles. Okay, suppose without there is without replacement, then it will be 5 by 11. 5 by 12 will become 5 by 11. So it's clear.
sir.
So I think it will be 1 3 5 by 36 is the correct answer.
Yes, sir.
C
It
option
is.
will be correct. Okay,
Yes, sir.
Yes.
so it's clear for everyone.
Yes, sir, it is
Yes,
clear.
it's clear.
Yes, sir.
Okay. Any doubt in this activity?
Sir,
No, sir.
Yes.
sir, can we say that whenever replacement is allowed, the events are independent? Like we are putting that in
No, you can't
back.
say in general. How you can say like with replacement, then they are independent.
Sir, we are putting them back into the our sample space.
Okay.
Then they are independent, I think.
Okay, so you are thinking like that. Okay. So first thing, it can depend on the situation as well. Right? Whether events are independent or not. Okay. So see, it can depend. I got your points. You are saying 4 by 12. Then I have again, I am independent to draw anything, right?
Yes, sir.
But thing is that suppose, okay, in this question, okay, in this question you are independent or it's a dependent.
Independent.
You are saying independent.
Yes, sir.
Okay, what is the meaning of independence?
Independence means there is no impact of happening one event on other.
One event of other event. Okay. So this is something meaning of, I mean, whether happening or non-happening of B, event B, there is no impact
There is
on
no yeah.
happening of event A. That is the meaning of independence. Okay. So,
Yes, sir.
I mean, but I don't, I mean, I'm not sure like you are saying when it's with replacement, then we can say it's independent. But yeah, we have to think like that. If it's the same as probability of E2, correct?
Um,
But here, what we can do, yeah, here it's a independent, right? Because probability of E2 given E1 is same as the probability of E2. But thing is that probability is same here, correct?
Yes, sir.
But we are kind of like it's the condition like first should be yellow, then it should be blue.
Yeah.
Are you getting?
Yes, yes, yes.
Okay. So there is something dependency kind of things in this question, right? So it depends on the objective of the question, I think, variety of the variations. Of questions. But for independency, we need to check this property. Is it okay, Jivraj?
Yes, sir. Yes, sir.
Oh. So anybody have any doubt in this activity 8.3? So do we move? It's clear this activity 8.3 till lecture 8.3 and activity 8.3.
Yes,
yes,
sir.
Yes, sir.
this one.
Okay. So any one of you had doubt this regarding activity 8.4? Which option are correct?
A and so first and last.
Yes, sir. First and last are correct.
Many times people go, no, they get confused like the joint and independent are same, but these two things are different thing. Okay, disjoint means there is no intersection. Okay, and independence means see, okay, simple. Probability of A uh, given B, I can write probability of A and B divided by probability of A, probability of B, correct? So from here, I can write probability of A and B equal to probability of A and B into probability of B, correct? So independence means this should be probability of A, this should be equal to, correct?
Yes, sir.
This is the meaning of when A and B are independent, okay? And When A and B are disjoint, that means what? There is no common between A and B. Correct?
Yes, sir. No effect on each other's.
Yes. So what's the probability of A intersection B? It will be probability of phi, that means 0. So
Yes, sir. Null
probability
event.
of A intersection phi is the A intersection B is the 0.
Yes, sir.
So this is the very basic difference between independent and disjoint event, right? Intersection of disjoint events will be 0, and intersection of independent events is the multiplication of individual probability. So this is the basic difference. So be clear with this, these two. Okay, it's clear for everyone.
So please tell once again this
Yes, sir.
dependent.
Okay, so disjoint means what? There is no common point between A and B.
Sir.
Okay, if you took the probability of A intersection B, so probability of phi is what? 0. Phi is nothing but phi. Normally phi is denoted for the null event. Okay, so probability of null event is always 0. So probability of A intersections B will be 0 for disjoint event, and if A and B are independent, then probability of A intersection B will be probability of A into probability of B. Okay.
Yes, sir.
Yeah. So it's a simple. These events and B are independent. So probability of A complement is nothing but 1 minus probability of A intersection B. So probability of A union B. You can find, right? I think this.
Yes, sir.
Okay. Any doubt in this activity?
No, sir.
Okay. So let's move for the next activity 8.5. Okay. So any doubt in this activity 8.5 in any question? Here you have to apply just concept of independence.
So can you explain the third one?
Third one, probability of a
Yeah,
flight
the
being
delay.
delayed
Yeah.
is 0.4, then probability of no delays on a round trip. Okay, so what was your approach, Sayan?
Sir, I just like roughly calculated the value, but it didn't work actually. So the delay is, I don't know if it's one way or round trip. So that was my confusion actually.
Okay, so
So
any
round
one
trip
of you
means
have
one
a
way then other, right? So it's kind of
round trip means going
going
and
and
coming.
coming.
Okay, so probability of delays given to me 0.4, correct? So
Yes, sir.
probability of no delay will be
One minus that.
1 minus probability of delay.
Yeah, I did that, sir. So far.
That means 1 minus 0.4, which is point.
0.6.
What the next? Probability of no delays on a round trip.
Yeah.
So probability of no delays on a round trip, correct? So what I can say, probability of no delay when flight is going into
Oh, so
probability of
okay. Oh, okay, got it, sir. Got it, sir.
no
And while
when
coming back, so the same value would be
right?
multiplied with each other. Okay, got it, sir.
Yes. So
I
it will
just
be
multiplied it with 2. That's why I wasn't getting.
it's clear
Okay,
now?
sir. Yeah. Clear, sir. Clear,
Yeah.
sir. Thank you.
Okay. So yeah. Any doubt in any question of activity 8.5? It's clear for everyone?
Yes, sir. No
Sir,
doubt.
haven't
So could you
completed
show
that.
the formula one more time, sir?
Which one? Which formula?
Yeah, no, the probability of no delay on a round trip.
Okay. Yeah. No delay while going should be while. I mean, there is some words are missing, so please adjust accordingly. But I'm trying. It's done.
Yes, sir. Thank you, sir.
Okay. Yes.
Sir, are these event independent?
That's why I have multiplied.
Yes, sir. Because it is independent event formula.
Yes. Actually, thing is that going and coming is independent here. Okay, you can consider it like that. Okay, so in activity, I mean in lecture 8.6, any one of you have doubt or related to in this activity? So here it's a simple things in activity 8.6. In the first question, what is it? Yeah, a male New Delhi resident is randomly selected. Which of the following pair or pairs of events A and B can reasonably be assumed to be independent? So here you have to think reasonably kind of thing. So what's should be correct option?
The first and last one.
First and
Last one. I mean, first and third.
yeah, it's a totally different. Suppose anyone is a doctor, so it's a independent thing. He has brown eyes, right? It's not
Yes, sir.
there is some dependency.
Yeah.
But in the B, there can be dependency. He had a body pain yesterday, and he was in an accident yesterday. Okay,
Even
Yes, sir.
B
There
is,
is
I think B
dependence.
is also, B cannot be assumed to be independent, sir.
no, no, it's something Sudarshan. You have to think reasonably. It's not like yeah, it's a fact. It's something like that. Suppose a
Yes.
person was in an accident, so it's something like that. He had body pain. It can be something relatable, right? It's not totally dependent. So it's here you have to think just reasonably. It's not. We have to assume it's not like it's a
Yes.
fact. Okay, so it's
Yes.
like that. Yeah. So like that.
Also,
See,
like he could have had a accident in the morning, then he'll surely have body pain
that
in
is the another thing. He
the
had an
evening.
accident in the
But in the
morning,
morning,
and he took painkiller and he had no body pain. So that is something else. So we can think a lot of, we can assume a lot of things, but yeah, it's something. That's why in the state question statement is clearly written that we have to think reasonably, assume to be independent. That's all. It's not like see in the third option, he's wearing blue suit and he used to drink coffee after reaching the office. So it's totally different thing, right? It's not kind of thing. So, and in the second question, it's also clear, right, for everyone.
Yes, sir.
Third is you have to apply the independence formula. Like it is asking about are A and B are independent or not. So you have to find. So is this independent or not?
No, sir.
Okay, because probability of A intersections B should be probability of A into probability of B. So probability of A is 0.8. So what will be the probability of B? Because it's a probability B complement is given to me.
Yes, sir. 1
So
minus B complement.
yeah, so 0.6 will be probability of B. So 0.8 into 0.6, it will be
4A.
0.48. So it is not equal to 0.4. And what about question number 4? It's independent or not?
So we just cannot say that we have 4 conditions. It's just one of
Yes.
them. So it's
So I
false.
think it's a false. Yeah, it's a false. Because why? Because see, for being independence of three events, this B, it should be like there should be some pairwise independence, right?
Yes, sir.
Yes, sir.
With A, B, B, A. No,
Yes.
sorry. A, B, B, C, and C, A. Like
For
this.
two events, we can directly say probability of A into probability of B, that then it will be independent. Okay. But suppose I have three events. So we can't say in general, yeah, intersection of these three is equal to multiplication of individual one. Okay. We need to find, I mean, there should be, these all should be pairwise independent. Okay. So it will be B intersection C, correct?
Yes, sir. And C intersection A or A intersection C.
Or yeah, both are same. If all these four are happening, then these three. Okay. So what about activity 8.7 or lecture 8.7?
So question number 6.
Question number 6, test for disease. Okay, how many of you have got the concepts of law of total probability or Bayes theorem?
Still didn't get to that lecture, sir. I
Yes,
think
sir,
Okay.
not
that's the
what
only lecture
last
that I
lecture.
need to finish.
Okay. Let me finish the concept of law of total probability and Bayes theorem. After that, I will come to that activity question so that you may, you will be able to relate the. Okay.
Yes, sir.
Okay. So what is the law of total probability saying? See, suppose I'm saying I'm taking an for two events, for example, then I will go for some. Suppose there is something, yeah, but there is two events, F and F complement, or let's say F1 and F2. Okay, this is my sample space hole, and I have divided. There is two events, F1 and F2, which are these F1 and F2 are mutually exclusive, exhaustive. So, what is the meaning of mutually exclusive and exhaustive event? This is nothing but the F1 union F2 should be S, which is there, correct?
So that is
So,
exhaustive, right?
yeah, sorry, that is meaning of exhaustive. Okay, so
Right.
F1 union F2 is S, that meaning of exhaustive. Now, suppose there is event, some any a different event E is occurring. Okay, so law of total probability comes into the picture. What is the probability of this event E? Okay, this is the something when law of total probability will come. So subject, I think, yeah. So how now we can proceed? How can write the event E? I can write event E like E intersection F1 when E will occur. Either E intersection C. Either this will occurring, then I can say E will occur, right?
Yes, sir.
Or I can say E intersection F2.
Yes,
Can I
the
say or
same
not?
logic on the both side. Yeah, yeah,
On
yeah.
the both side, correct? So
Yeah.
it's a union for event E,
Yes, sir. Yes, sir.
correct? For happening of E, it should be E intersection F1 and uh, E intersection F2, correct? So far it's clear.
Yes, sir.
Now, what we can do, just we can apply the probability of E, which is nothing but probability of E intersection F1. I said these are mutually exclusive and exhaustive. So meaning of mutually exclusive means uh, they are
Disjoint.
disjoint. That means uh, intersection part will be 0. Intersection part will be what? Of what? This event and this event. Okay. Now we have these things. So by the uh, concept of multiplication rule, I can write probability of E given F1 into probability of F1 or not,
Yes, sir. Multiplication rule.
correct?
Yeah.
Or simply you can say for this blue region, I can say probability of F1 has occurred and what's the probability of E when F1 has occurred. I can say or not for this first blue region, correct? I
Yes,
mean,
sir.
are you getting?
Yes, sir.
For probability for this blue region, second blue region, suppose I'm saying probability of F2 into probability of E when F2. I can say,
Yes, sir.
eh?
Yes,
So
same as before.
same as the before. Okay. So this is nothing but the law of total probability is called. Okay. Probability of E nothing but probability of E given F1 into probability of F1 plus probability of E given F2 into probability of F2. So this is something called the law of total probability or rule of total probability, both the same things. Okay. It's okay. Similarly, we
Yes.
can think like for 3 to for more events, like you can say like, yeah, similarly, suppose I have F1, F2, so on, let's say Fk. Okay, suppose this is for F1, F2, so on. This I have Fk events, K events are there, and there is a event E is occurring. Okay, so what's the probability for event E? So it can be E intersection F1, okay, union E intersection F2, union, so on. It will be union of E intersection F of K.
K.
Okay, so what's the probability of E? So see, be careful. If all the F1, F2, Fk are mutually exclusive and exhaustive events. So mutually exclusive means they are disjoint. So if they are disjoint, then E intersection F1 will be also disjoint to E intersection F2. I mean, this event will be disjoint to this event.
Yes, sir.
Correct. So
Yes, sir.
that means intersection part will be 0 for this and this. So not this intersection part. I'm asking.
So it's the union intersection part. I mean, the extra
Yes.
union that
Yeah.
that one, right?
Intersection part of this event and this event, okay, will be 0. So it will be probability of E intersection F1 plus probability of E intersection F2 plus so on plus probability of E intersection Fk. Correct? And we can multiply the, we can use the multiplication rule, which is probability of E intersection F1 into probability of F1, so on. We can write for the E intersection of F of K into probability of F of K. And in general, you can write summation I is equal to 1 to K, probability of E given F of I into probability of F of I. So this is something called the base, sorry, not base, law of total probability. Okay. So it's clear for everyone, this law of total probability. I will take an example,
Yes, sir.
okay, and this will be clear. Now come to the base rule. Base. Okay. So what's the base theorem here? Base theorem is like conditional probability. Conditional probability means suppose okay. Here when I had F1 and F2, correct? And there was event E. And we for law of total probability, we were interested in what's the probability of E, correct? So what was that? This was nothing but probability of E, probability of this one. Okay. So probability of E given F1 into probability of F1 plus probability of E given F2 into probability of F2. This was the probability of E. So far it's clear.
Yes, sir.
Okay.
Yes.
Now Bayes theorem is saying what will be the probability of let's say I'm saying F1 when E has been occurred. It is saying that what will E has been occurred, it's given, then what's the probability it has been occurred in F1? Are you getting?
Yes, sir, we are getting.
Yes, sir.
So here I can apply the conditional probability formula. What I can write, probability of F1 intersection E divided by probability of E, correct?
Yes, sir.
Probability of E we have already found by the law of total probability. Now we need to find this quantity. How we can find probability of F1 intersection E? I can write probability of F1 into probability of E given
Yeah.
F1 or not.
Yes, sir.
I can write
Yes, sir. From multiplication rule.
from the
Yes, sir.
multiplication and divide by probability of E, which is this is the base theorems you can say, or you can write as probability of F1 into probability of E given F1 divided by C. You can see this is the same as this one for this quantity only. Okay. So it's the probability of E given F1 into probability of F1 plus probability of E given F2 into probability of so
F2.
this is something the base rule. That's all. I mean, it can be expanded for 3 to 4 events, but for 2 events, so it's clear. Base theorems and who had asked about that?
Yes, sir, it is clear. But
It's clear now.
is it useful?
Yes,
Yeah,
sir.
it's
Please.
useful. Okay, I'm going to take one example. I think that will be helpful for you. Okay.
Sir?
Yes.
Sir, will they ask like a proof for like base theorem in exam?
No, not at all. Just application.
Okay.
Okay, so I'm going to take an example by which I think you will, I mean, multiplication rule and law of total probability and base theorem will be clear. Okay. So suppose I have two fridge. Okay. This is fridge 1 and this is fridge 2. Okay. And I'm saying probability of choosing the fridge 1 is not randomly, means suppose I said I can choose any fridge. That means then probability of choosing the F1 and probability of choosing the F2 will be half. Then I will say it's a randomly. I can choose any of the fridge, right? But I'm going to assign a probability, like probability of choosing the F1 is 3 by 4. I mean, it's you can assume like you enter a room or a kitchen, there is a first fridge and then second fridge. So choosing the first fridge have more probability, right? I mean, just taking this example. Okay. So for probability of F2 is 1 by 4. Okay. And I'm saying in the fridge 1 there is 5 dark chocolates, 3 white chocolate, and in the fridge 2, 2 dark chocolate and 6 white chocolate. Correct? Till this point is clear?
Yes, sir.
Okay, nice.
Yes.
So first question I'm saying, what is the probability of choosing a white chocolate from fridge 2? Yeah, please mute Satyanath Kumar. Choosing a white chocolate from F2 I'm writing. So what is meaning? I can say white chocolate and fridge 2.
Yes, sir.
Correct?
Yes, sir.
What is this? First probability of F2
F2 and
into probability of choosing white chocolate given F2.
given F2.
Given F2. Yeah.
Correct?
Yes, sir.
That is what? This is the nothing but the multiplication rule.
Yes, sir.
So what is the probability of F2 is 1 by 4 into what's the probability of W given F2. So W given F2 means I need to consider the only fridge 2. So what's the probability of white chocolate in fridge 2?
2 by 8.
6 upon 8.
6 by 8.
6
6
by
by
8.
8. 6 by
Sorry,
8.
Correct?
sorry.
So I mean, just compute the final value, what it will be. I'm just going to describe the fundamental concept. Okay, so it's clear. Here I can apply the multiplication rule. Okay, now second question, suppose statement is like, what is the probability of choosing a white chocolate? Right? So be careful. Here I'm interested in only what is the probability of choosing a white chocolate. How I can apply? Which method you can apply? So just tell me. Just think for a minute and tell me.
Law of total probability.
Correct.
Yes, sir.
And
Law
why?
of total probability.
See, it's a probability of choosing a white chocolate. That means probability of choosing a white chocolate, and it is from fridge 1, or probability of white chocolate from fridge 2. Okay, this is nothing but the law of total probability. Law of total probability, how? Because I can write these things as probability of fridge 1 into probability of white chocolate given fridge 1 or probability of F2 into probability of white chocolate E. Are you getting this point?
Yes, sir.
Okay. So what is the probability of choosing the fridge one? It was 3/4 into probability of white chocolate given fridge one. It's 3 by 8.
3/8, sir.
Okay. Plus it's a this thing is same as these things, right? So 1/4 into 6/8. Okay. Now it's clear till this point.
Yes, sir.
Yes, sir, it is clear.
Now come to the next statement. Suppose I'm saying, okay. Suppose I'm saying, what is the probability that, okay, suppose you have given that you choose a white chocolate. Okay. Then find the probability. I mean, what is the probability that it was chosen from fridge 2. That means F2. So what is it is asking about? What is the probability that, I mean, it's given that white chocolate it's already chosen, correct? What is that probability that it is from fridge 2? Correct. So is it same as these things? What is an event has been occurred? White chocolate I have chosen. What is the probability that it's from fridge 2? I mean, here is you can assume F1 as fridge 1. So I can take for fridge 1 as well. And what's the probability for it is chosen from the fridge 2 when I have chosen already one white chocolate. So I can write, it's clear. So
Yes,
I
sir.
can write probability of F2 intersection W divided by probability of white chocolate. Okay. So what is this? Probability of F2 intersection W. This is nothing but these things I have computed.
Yes, sir.
And what is the probability of white chocolate? These things. So we have to just put the value. I mean, these things I can write probability of F of 2 into probability of white chocolate given F2 divided by probability of white chocolate. So previous thing is 1/4 into 6/8. So it will be 1/4 into 6/8 divided by will be there this quantity. Okay. Similarly, I can ask if white chocolate is chosen, then what's the probability it is chosen from the fridge one? So it will be probability of F1 intersection W divided by probability of W means white chocolate. So probability of white chocolate is same. So these things will get changed in the numerator. That's all. Similarly, you can consider for the dark chocolate as well. So it's clear, Bayes theorems and independence
Yes,
and
sir, it is clear.
multiplication rule and law of probability.
Yes, sir.
Yes, sir.
Okay. So just tell me this activity 8.7, any one of you have any doubt?
Question number 4, sir.
Question number 4. Okay. So what was your approach? Can you tell me first?
Uh, Sir, I first assume that all three students can be equally likely be chosen. So 1/3 is the probability of choosing a student, and then the probability of making correct answer by Riddhi is 1/2. Completing a task is 1/2,
Task.
and plus the 1/3 of probability of the choosing Simans, and then multiplied with the probability 1/4 for completing the task by Simans, and then adding the probability of choosing Pratik multiplied with the probability of completing the task by Pratik, and it comes out to be 7/24 from my side.
7/20.
I use total probability theorem.
Okay, so you had applied total. Okay, that is the something there is not there because see, task is given to three students, Riddhi, Shivans, and Pratik. Correct? The probability of completing the task individually, right? It's is 1/2, 1/4, and 1/8. Correct?
Yes, sir.
So it is asking about find the probability that task is completed. So when task will complete it?
If either of them complete the task.
Either of them completed the task. Okay. So far so good. Okay. Any one of you have attempted this question? Anyone?
No, sir.
Yes, sir. Yes, sir.
Okay. So what was your approach, Satna? I mean,
Sir, question number 4, no, sir?
yes, yes.
Sir, in question number 4, my answer is 43/64. What I have done, the question is asking if the probability of completing the task given, then find the probability that the task is completed. So in
Yes.
all the 3 cases, I found that the task is not completed. That is
Okay.
1/2, 3/4, and 7/8. So I multiplied all the 3, that task is not completed. Then 1 minus that gives the answer.
Correct. So what's the A? A is nothing but, I mean, I can define the event A. Completing a task. Okay. So task is completed by?
Anyway, task is
Ready.
completed by any one of them.
Oh,
so
yes.
I found first task is not completed, then 1 minus
Correct.
that.
Correct. So Shivans and Pratik. So probability of, I mean, event B is task is completed by Shivans. Okay. And task is completed by Pratik. Correct. These three candidates are there. So the question is, find the probability that task is completed. Okay. So when task will be completed? When any one of these three have done the task. Correct. So task is completed means I can say probability of A union B union C, A or B or C. It's clear?
Yes, sir.
What I can write by the De Morgan's law, I can write, okay, I can write 1 minus probability of A union B union C whole complement.
Yes, sir, we can.
Yes, sir.
I can write by the De Morgan's law. In the last session, I have told you if A union B complement is there, that means A complement intersection B complement.
Yes, sir.
So what I can write 1 minus probability A complement intersection B complement intersection C complement.
Yes,
Yes,
sir.
sir.
Yes, sir, we can.
Since these are three different person and we have given the probability for individual, I mean probability for completing the task individually, right? It's not there is something dependency between the Shivans and Pratik. Correct? So if A, B and C are independent, then A complement and B complement and C complement will also be independent. So 1 minus I can write probability of A complement into probability of B complement into probability of C complement. Okay. So it will be 1 minus probability of A complement will be 1 minus what's the probability for 1/2? 1 minus 1/2 into 1 minus
1/4.
into 1 minus
1/8.
8. So it will be 1 minus 1/2 into 3/4 into 7/8. So it will be 1 minus 21/64. So it will be 43/64. This is that.
Sir, but I cannot figure out where I was wrong in that approach. Why is it
Okay.
not applicable there?
See, What is the law of total probability is saying? See, you are going to select the individual person. Okay, see, one thing you can do, like, see, I have these Riddhi, Sivans and Pratik, correct? When task will be completed? Suppose Riddhi has done and these two have not done, correct?
Yes, sir.
Say
If
Riddhi has
I
not done, Sivans has done, Pratik has not done.
I got it, sir. In this way we can calculate.
Okay,
Thank you,
these
sir.
things. Or there will be a lot of cases like these two have completed, one not. These have completed, Sivans not completed, Pratik have completed.
I was just calculating whether they have completed one
Yes,
have completed. I was
you
not.
have done.
Hmm.
Yes, so this will be like that, and there will be, I think, one more cases for all, correct? So you are doing this one, right? You are not doing for the
Yes,
remaining
sir.
cases. Okay,
Yes, sir. Hmm.
now it's clear.
Yes, sir.
Okay, okay. So anything else in activity 8.7?
Sir, I have
We discussed the last question.
number 6. So I have already done now, as you explained how to do Bayes theorem and law of total probability.
Okay, okay. So
But now
it's
I'm stuck with question number 7, sir.
okay. So question number 6 you have done, right?
Yes, sir. Yes, sir. The way that time what you explained, sir, for that with that help I could do it, sir.
Okay, okay. I mean, you are able to do the question related
Yes,
to
sir.
that.
Yes, sir. 6 I have
Okay.
done. Yes, sir.
Okay, nice, nice, nice. So we'll do the 7th. Just give me a minute. Let me connect my laptop to charging. Okay. Yeah, just give me a minute. Okay, so in the 7th, can you tell me what was your approach so that I can know where you are getting?
Sir, initially itself, how to take the events that I cannot understand, because
Okay, so
the question is asking,
okay,
given that it is cricket and you have to find probability of football.
no, so see, when you are going to solve any question, mathematical question, things, so just try to do like what the things are given. Okay, just write down.
Yes, sir.
Okay, that will help you. Okay, let me read the question. Suppose that in IIT Madras, 40% of students are girls. Okay, that means remaining 60% are boys. Okay,
Yes, sir.
okay,
Yes.
just we will go step by step. Yeah, 40% of the students are girls. Okay, so that means probability of G is, I'm going to denote G as girls. Okay, it's 40%. That means 0.40.
Yes, sir.
So probability of B will be
0.6.
Okay, now
Yes.
it is known that 70% of the boys play cricket. Okay, it is saying that, and 60% of girls play cricket. Okay, okay. That means, can I say probability that boys is given and they play cricket is 70%?
Yes, sir.
Can I say or not?
Yes, sir.
Similarly,
Yes, sir.
probability of, I mean, 60% of the girls play cricket. That means, once again, probability of girls, I mean, it is given that 60% of girls play cricket.
0.6.
Okay, we can draw a Venn diagram once. That will be, I think, easy.
Then further football.
One second, let me draw a Venn diagram. Suppose it's a 40% are girls, 60% are boys. Okay, so I can, this is for girls, this is for boys. Okay, so this region is for girls. Okay, this region for is boys. Okay, it is saying that 70% of boys playing cricket. Okay, that means out of, see, these are total boys. Okay, and these are total girls. So out of these total boys, 70% of the boys playing cricket. Okay, this is for cricket. That means, see, there are, I don't know in numbers how many boys are there, but out of these boys, 70% are playing cricket. That means this blue region boys are playing cricket.
Yes, sir.
Correct. Now,
Yes.
in the question, it is saying that 60% of girls play cricket. That means out of this region, girls region, 60% are playing cricket. That means this light blue region are for girls who are playing cricket. That means these things, right? So far it's clear.
Yes, sir.
Now come to the next. While 40% of boys play football and 50% of girls play football. Okay, so there is another event for football. So I'm going to denote by, suppose this is the football, red region. Okay, it is saying that how many percent?
40% boys.
40% football. Yeah. So somehow its region is more than 40%, but we can, I mean, just try to interpret this yellow region are boys who are playing football. Okay, and 50% girls. So this yellow region is girls who are playing football. That means in mathematical notation, what we are given, probability of boys football is
4.4.
and probability of girls, what is the probability for playing football is
0.5.
0.5.
50%.
Okay, now come to the next statement. So next statement is saying, given that 33% of those who play football also play cricket. Given that 33% of those who play football also play cricket. Okay, okay. So out of this whole red region, it is given that 30% who play football also play cricket. That means probability of cricket who play football, it's 33%.
Yes, sir.
Correctly?
Yes.
Correct. Next statement is, a student is chosen randomly chosen, and it is known that students plays cricket. Okay, what is the probability that students plays football? Okay, so we need to find, it is given that students play cricket. What is the probability that he play football? That's the things we need to find out. Correct.
Yes, sir.
Now, so what we can do, so probability of F given C, that means probability of F intersection C divided by probability of C. Can I say or not?
Yes, sir.
And what is the probability of F intersection C? How I can find probability of F intersection C?
Sir, is it 0.33? Because those who play cricket also play football.
So it's
It is 0.33 probability of F.
No. See, probability of F intersection C, I can write probability of F.
C. Sorry, F.
C given F.
C given F.
C given F. Yeah.
Yes, sir.
See, it's right, football and cricket. So I can say probability of football into probability of cricket given football. Correct?
Yes, sir.
Now, the thing is that in the question, we are not given probability of F and probability of C. Now,
Yes,
we need to find the probability of F individually and probability of C individually. So this is something you can relate with the dark chocolate and white chocolate. What's the probability that chosen chocolates is C? You can relate with, yeah, what the property that choosing a white chocolate, so it's a white chocolate from fridge 1 or white chocolate from fridge 2. Similarly, I can do for probability of dark chocolates and fridge 1 plus probability of dark chocolates from fridge 2. I can do or not?
Yes, sir.
Yes, sir.
So same things we can do here, like there it is. Yeah, probability of F means what? Probability of football, I mean playing football
Yes,
and
sir.
girls, or probability of F or boys.
Boys.
Like probability of white chocolate. So probability of white chocolate intersection fridge 2. Probability of white chocolate intersection fridge 1. Correct? Now,
Yeah.
so what I can write here, probability of girls into probability of F given G
Given G.
Yes, sir. F given G.
plus probability of boys into probability of F given B.
F given B.
Okay? Let me erase these things. Yeah. So probability of G is given to me 0.4. Correct?
0.4.
Into probability of F given G 0.5.
50.
Correct? Plus probability of B is 0.6.
0.6.
Into
So
0.4.
probability of F given B is 0.4.
0.4. So 0.double.
So it's the 0.22. No, sorry,
0.4 into
0.20
1.1.
plus 0.24.
Yes.
So it's a 0.44. Correct? Now
Yes, sir.
we have found out probability of F. Now we need to find the probability of C. And since probability of C given F is given, I mean this quantity we know, this quantity we have calculated. Now we need to calculate this probability of C, right? So how we can find the probability of C? Can I write probability of C cricket and girls or probability of cricket and boys? Correct?
Yes, sir.
See. So you can see simply things. Cricket means I mean probability of cricket means playing cricket by girls, union playing cricket by boys. I will apply the probability, you will get this. So here I can write probability of girls into by the multiplication rule, probability of C given G plus probability of boys into probability of C given B. Correct? So probability of girls is 0.40. And what is the probability of C given G? So 0.6 and C given B is 0.7. Okay. So 0.60 plus 0.6 into 0.70. So it will be 24 plus 42, right? So it's a 0.66. It's clear or not? And are you getting my point?
Yes, sir. Yes, sir. Clear, sir.
Yes, sir.
Yes, sir.
What is the thing? Probability of F. We can put the value. Probability of F is 0.44. Correct? Into probability of C given F is 0.33. Divided by probability of C is 0.66. So what it will be? 0.22.
Yes,
See,
sir.
this 0.22. I mean,
Sir,
this will be
0.22.
2. This will be 2 and 0.22. Let me check the answer. Yeah, 0.22 is the correct answer. So is it clear, this thing?
Yes, sir.
Yes, sir. Clear, sir.
Yes, sir. It is clear.
Yeah. So anything else? I think I have covered all activity. Or any doubt in practice assignment, week 8 or any concept? Okay, so is there any doubt? I mean, week 8 is clear, right, for everyone? Hello.
Yes, sir. So far we can say that.
Sir, we haven't I haven't completed all, so I cannot comment right now. Maybe in the next open
I
session,
mean,
will ask.
the things we have discussed here, is all the clear or not?
Yes,
Yeah,
sir. They
yeah.
are clear.
These things are clear, right? Okay,
Yes.
so if it's this case, so I can assume like you can solve the questions of practice and graded assignments. So is there any doubt in week 7 graded assignment? Or all the questions, I mean, you were able to solve all the questions?
Sir, I got 3 questions wrong.
Okay, and which one? Is the first question, I mean,
Yeah,
everyone
first question is
was able to
okay.
do the first question? It was, I think I can remember there was a similar question in the solve with the session, like exactly two numbers between the two alphabets. So the same concept you have to apply there. So first question was clear for everyone?
Yes, sir.
Yes, sir, it is clear.
And what about second?
Second is also clear, sir.
So is this for everyone?
Yes, sir, it is clear.
And what about third?
Sir, I got third question wrong.
Okay, third, I mean, remaining people for the rest of the people.
Yeah, clear, sir.
Okay, so I mean, numbers might be different, but it's different for everyone. So a person predicts. I will just give you a hint. Okay, I'm not going to do the whole calculus, but yeah, more or less a concept. Yeah. So a person predicts daily whether the price of stocks of wristwatch companies will go down or up. I mean, up or down. If his prediction on stock price of Titan is correct 4 times out of 8, right? So what is the meaning of 4 times out of 8? That means, see, I can define events like in the probability thing, just read the every statement and try to write each and everything. So you can define event A. So first is prediction of stock price of Titan. Okay. So I'm going to do like prediction of Titan. It's correct. Okay. And B, prediction. See, that person is doing the prediction for Rolex also. So prediction for Rolex is and prediction for 4G. Okay. So prediction for of Rolex is correct. And I'm going to define event C. Prediction of fossil is correct. Okay. These three I have defined. These three events are. So what is the probability that at least two of his prediction are correct on a given day? Okay. So it is asking about at least two prediction. Correct. So first thing, what we can do, see, at least two prediction.
Sir, I
So suppose
understand like it must be something like we should
it's
take
yeah,
0 and the first prediction and then we have to minus it, right?
yes, kind of. So suppose this is the Titan, R for Rolex and F for 4G. So prediction for at least one is no, it's for at least two. So suppose for the Titan prediction is correct, for Rolex prediction is correct, for 4G it's not, right? For Titan it's correct, for Rolex it's not, for 4G it's at least two means uh, greater or equal to 2, correct? So suppose for Titan prediction is wrong, for Rolex is correct, for Fossil is correct, and last case can be
All are
correct.
correct.
All are correct. So we have to add all these four possibilities. Okay. So what is the probability for A? It's 4 times of out of 8. That means 4 by 8.
4 by 8.
And what is the probability of B? 2 times out of 4.
2
That
by
means
4.
2 by 4. And what is the probability of C? 2 times out of 9. That means
2 by 9.
2 by 9. So what is the meaning of this thing?
Sir, for each correct, we can multiply, but for each wrong, we have to first minus that from 1, then multiply.
Yes, then multiply. See, why we can multiply? See, we have to consider at least 2 prediction as correct. So, see, for these things, I can write A and B and C complement.
C complement.
Are you getting? I don't know her name who has asked this question.
Yes, sir. I'm
Plus,
getting.
for this event, I can write A and B complement and C,
Yes, sir.
or A complement and B
A
and C,
complement B and C.
plus A and B and
B
C.
and C.
Okay. So probability
Okay.
that at least 2, we have to add all the possibilities. Probability of A complement, sorry, A intersection B intersection C complement, plus probability of A intersection B complement intersection C, plus probability of A complement intersection B intersection C, plus probability of A intersection B intersection C. See, first thing, second thing is prediction are here independent or not?
Yes, sir. They are independent.
They are independent.
Independent, sir.
It doesn't not matter. Okay, so you can do probability of A into probability of B into probability of C complement, plus probability of A into probability of B complement into probability of C. Since these all are event are independent, so probability of A complement into probability of B into probability of C, plus probability of A into probability of B into probability of C. So just put the value. Okay, probability of A, probability of B. So for probability of C, it will be 1 minus 2 by 9. Okay, so similarly for the rest of the things, will
Okay, sir. Got
you
it.
be able to do it?
Yes, sir. I'll do
Yeah.
it
Okay.
now.
Yeah.
Yeah.
And you know, if suppose for anything, any event A and B are independent, then I can I mean, it's A complement and B complement will also be independent. These things, you know, or should I derive?
Yes, sir. Please derive it.
Please derive.
Okay.
Okay, so A and B are independent. Okay,
Okay.
so when A and B are independent, that means probability of A complement into probability, sorry, probability of A into probability of B.
Probability of individual multiply.
So for being independence of A complement and B complement, it should be probability of A complement intersection B complement should be multiplied by individual probability, right? So if A complement intersection B complement, so I can write probability of A union B whole complement or not?
Yes, sir. Yes, sir.
Right? So, and 1 minus probability of A union B or not?
Yes, sir.
Yes,
Correct?
sir.
So 1 minus probability of A union B, probability of A plus probability of B minus probability of A intersection B or not? Can I write?
Yes, sir, you can.
Correct?
Yes, sir.
So
Correct.
1 minus probability of A plus probability of B minus, see, I said
Now
A
I
and
got
B
it.
are independent. So probability of
In,
A into probability of B, I can write
yes,
in the
sir.
place of these things. Correct?
Yes, sir. Yes, sir.
So I can write 1 minus probability of A, just minus will go inside the
You're
bracket.
opening the bracket. Okay.
Okay. So plus probability of A into probability of B.
Yes,
So
sir.
1 minus probability of A. If I will take probability of B as a common, so it will be 1 minus probability of A from these two terms.
Yes, sir.
Okay. So I can see, you can consider this as a one term. So I can write 1 minus probability of A
1
into
minus
1 minus
probability of B.
probability of B.
Yes, sir. Yes, sir.
What are these two? Probability of A
A
complement.
complement and B complement.
A complement and B complement.
That means these two are independent. That
Independent.
means suppose I'm saying if A and B are independent, it is given to us. That means A complement and B are independent.
Yes, sir.
A and B complement will be independent.
Yes, sir.
A complement and B complement will be independent.
They
So
are
thing is that
also
you have to
independent.
just put the value here. Okay. See, if I mean you will get these things. I mean in the last you will get for A complement and B, you will get like 1 minus probability of A into probability of B. Okay, after deriving this. Okay, I mean, you have to start by this A complement intersection B. So what you can write for this, and you have to, I mean, you can proceed like this.
Yes, sir.
Okay?
Yes, sir. Yes, sir.
Okay, it's clear.
Yes, sir.
Yes.
It's clear
sir.
now.
So any doubt in question number 4?
No, sir.
It was clear. It's when you will draw a Venn diagram, question number 4 is very much easy.
Yes, sir. By Venn diagram, it is easy.
Yeah, it was clear for everyone.
Yes, sir.
Okay, so what about question number 5? It's I think addition rule. Yeah, event A is given to you, A intersection B is given to you, and A union B is given to you. It's asking about event B. That's all. Just apply the addition theorem of probability. Is that okay?
Yes, sir.
And question number 6. Clear for
Yes, sir, it
everyone?
is also clear.
Yes, sir. Yes,
Yes,
sir.
sir, it is
Here,
clear.
there is no need of these two.
So it's just 1 minus that union value.
Yeah, just
that's
one
all.
minus.
But it's for just we are given for whether your concepts are clear.
Just to confuse.
Yeah. So this 7 is clear or not? I mean,
Yes, sir, it is also clear.
there was a similar
Yes, sir.
question in the solve with this, that was some, I think, ball and all, right? Or something there was, I don't know that. Question number 8,
Yes, sir.
9,
7 I got
Yes,
wrong.
sir.
7 you got wrong.
Yes.
So question is 7 cards are drawn at random without replacement from a pack of 52 cards. So in how many ways you can draw the 7 cards?
The assignment 7.
52 C7.
52 C7. Yes, sir.
52 C7, right?
Yeah.
So you can draw 52. I mean, this is the total number of ways in which I can
7
draw
cards are
7
drawn.
cards from 52 cards. Correct?
Sir, 4 cards are drawn.
No, it's a different for everyone. Okay, okay. Tell me, 4 cards are drawn without replacement from a pack of 52 cards. Then how many black and how many red we have to draw?
2.
2 black and 2 red, right?
Yes, sir.
So it's a simple thing. So I can choose 4 cards out of 52 in 52 C4,
Yes, sir.
right or not?
Yes, sir. Yes.
And in how many ways you can choose 2 black cards?
26 C2.
26 C2.
Because in pack of 52 cards, 26 are black, 26 are red. Out of these black, 13 are club, 13 are spade, okay, and 13 are heart, and 13 are diamond. Okay, these are something. So we have total 26 black cards. So I can choose 2 black cards in 26 C2 way.
Yes, sir.
And another was 2 red. Okay, so you're saying 2 red cards. So in how many ways you can choose 2 red cards?
Same, sir. 26 C2.
So what's the probability for choosing a red card and black cards?
So 26 C2 into 26 C2 divided by the total number of cases, 52 C4.
That's it. Is this clear now?
Yes, sir.
Yeah. So what about question number 8? It's claws are of different types. So how many claws are? 5 shirts, 5 pants, and 11 t-shirts. Yeah, so it will be 5C1, 5C1 into 11C1 divided by total. I mean
total cases.
21 divide 21C3. Okay. So again, it's a randomly chosen class does not contain point. That means we have to choose the 3 class from shirts and t-shirts. So it will be 16C3 divided by total. Correct?
Yes, sir.
For 10, similarly, it's at least one of the class is shirt. That means 1 minus probability. No, I mean, there is no shirt. There is no shirt means we have to choose from pant and t-shirt. Okay. Till 10, it was clear for everyone.
Yes, sir.
Yes,
What
sir.
about 11?
So 11th I got wrong. You explained me in the last class, but I couldn't do it. I selected first option, but
Mhm.
it couldn't come out correct.
Okay, any one of you have done it in correct way?
Yes, sir.
Okay, what was your approach? Okay, let me do it. Okay, so question is saying an arc contains three balls, random 1, 2, and 3, right? Coefficient
Yes,
of
sir.
equation px square qx plus c equal to 0 is determined by drawing the number of balls with replacement. What is the probability that equation will have imaginary roots? So for being the imaginary roots, the value of d, that means suppose I have equation of ax square plus bx plus c is 0. That means value of b square minus 4ac is less than 0. That means I will get imaginary roots. If it's greater or equal to 0, then I will get real roots. So far it's clear.
Yes, sir.
Now,
Yes, sir.
so I have equation px square qx plus c equal to 0. So okay. See, in the question it is written that we will get the coefficient of equation by determine the drawing of the numbered balls. So in how many values coefficient p can take? It can take, p can take any value for 1, 2, 3 because ball are numbered 1, 2, and 3,
Yes,
and
sir.
q can
Yes,
take
yes.
any value between 1, 2, 3, and c can take any value 1, 2, 3. It's clear. See what question in the question it is written that the coefficient of equation p, I mean what are the coefficient p, q, and c, correct, is determined by the drawing the numbered balls with replacement. And how many numbered ball we have? 1, 2, and 3.
Yes, sir.
Correct. It's clear.
Yes, sir. Sir, I also did the same, but
Okay.
23.
Okay. Yeah. It's 1 second. So it's a 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So total number of possible outcomes is what?
Sir, 27.
Total number of
Total
possible
is
outcome.
27.
It will be 3 into 3 into 3. That is 27. Till this point, it's clear.
Yes, sir.
One
Yes,
thing.
sir. This is clear.
We are interested in the imaginary roots. That means value of p square minus 4qc should be less than 0.
Yes, sir.
Yes, sir.
P square or
Q square.
oh,
Q square
sorry.
minus 4pc.
Q square minus 4pc should be less than 0 because you have equation ax square plus bx plus c. If then value of d is what? B square minus 4ac. So in the place of b we have q, correct? So this
Yes,
should
sir.
be less than 0. So can I say as 1 minus probability, not probability here, 1 minus or q square minus 4ac greater or equal to 0? If I'm talking about probability, can I say or not?
Yes, sir.
Are you getting it?
No,
Okay, okay.
so
Oh, 1
this
second.
one I couldn't
So
get it.
what is the
Yes, sir. Yes,
probability
sir.
of 1 second? What is the probability of A complement? 1 minus probability of A.
Yes, sir.
Suppose I have probability of okay, so same things I can say probability of A is 1 minus probability of A complement.
Yes, sir.
Okay. Suppose my A is I'm interested in imaginary roots. Okay. Suppose I'm interested in imaginary roots.
Okay.
So can I say 1 minus probability of real roots?
Oh, got it. Got it now.
So probability of imaginary roots is what? Q square minus 4 PC less than 0. That means 1 minus probability of Q square minus 4 PC greater or equal to 0.
Okay.
So this is condition for imaginary roots. So this will be condition for the real roots. Correct?
Okay.
Why I have taken this? Because it will help for doing the calculation in EG. Okay. So we need PCQ. So let me make column of PC. then this is P, then this is C, then let me make 4PC. Suppose my Q is such that I'm going to make a column of Q. I mean Q means the value Q can take such that Q square minus 4PC should be greater or equal to 0. Okay. So suppose my PC can take value 1 and 2. Only in this, these are the two cases in which my Q square minus 4PC will be 0, because suppose I'm taking the maximum value of Q as 3. See, ball are numbered 1, 2, and 3. Suppose you will take value as 3 for Q, so maximum will be 9 minus, correct?
Yes, sir. Correct.
Multiplication of PC will be 3. That means 4 into 3, 9 minus 12. It will be less than 0, which is not correct here. Are you getting what I'm
Yes, sir.
trying to say?
Yes, sir. Negative.
So, yeah. So thing is that here value of PC will take value 1 and 2. Okay, forget about it. So suppose P is taking value 1 and C is taking value 1. Only this is case when PC will be 1. What is value of 4PC? 4. Correct?
Okay. Okay.
What will be the value of Q square minus 4PC?
But sir, can we take one like
What's
for
it?
both the values? Because I didn't take that option. I just took like for P if I'm taking 1, then C is I'm taking 2, and then for
Okay,
Q
okay.
I'm taking 3. Like, but I
No, no, no,
haven't
no.
taken like 2, 2, 2 or 1, 1, 1.
1 second, 1 second. What I'm trying to say here. Can you tell me, suppose value of P? Okay, okay, let's go by this one. Suppose P is 1, C is 1. So value of PC is 1, 4PC will be 4.
4, yes.
So for this case, what value Q will take such that Q square minus 4PC will be greater than 0? So Q can take, Q will not take 1 here. Q will take 2. Okay. Suppose here Q will take 1,
It
so
will
it will
be
be 1 minus 4, which is negative. But I have to take
negative.
the value of Q such that Q square minus
Equal to
4PC
0.
is greater or equal to 0. So suppose I'm going to take value of Q as 2, it will be 4 minus 4, which is equal to 0.
0, yes.
So here Q can take value 3 also.
Yes, it will be greater than 0 then.
It will be greater than 0. Now, suppose P is taking value 1 and C is taking value 2. So P into C will be 2.
Yes.
What will be value of 4PC? 8.
8.
Now,
Yes.
what value Q will take?
3.
Only 3, because in case of 2, it will be negative.
Yes.
Because if you will take 2, it will be 4 minus 4PC is
Yes.
8, it will be negative. That
Negative,
means
yes.
if you will take 3, that means 9 minus 8, which is greater or equal to 0. Okay.
Yes.
Suppose P is 2, C is 1. Again, it will be 2.
Yeah.
4PC will be 8. Again, Q will
Yes.
take value 1.
3. Yeah.
I mean 3.
3. Yes.
Now, suppose it is taking 1 and 3. So multiplication will be 3.
Yes.
4PC will be 12.
12.
So what value Q should take?
It should be greater than 3 then 4.
There, but there is no 4. There are
No
only
4,
1, 2, 3.
yes.
That means there will
Yes.
not be cases.
Yeah.
Only this.
Yes.
Okay.
Yeah.
So for how many cases we have? These are the only 4 cases.
Yeah.
2
That's
cases
why I
for this.
selected
1 case is for this one. 1 case. So it's a 4 by 27 for real
yeah.
roots.
For real root,
But
yes.
we
I
are
should have
interested in the imaginary roots. So it will be 1 minus 4 by 27. So it will be 23 by.
Okay, got it, sir.
So it's clear now?
Yes, yes. I haven't done so I haven't subtracted from 1. That
Okay,
was
okay. So be clear with this. Okay.
okay. Thank you, sir.
Okay. Anything else? Anybody?
Sir, can you discuss question number 2 in the assignment?
Graded assignment?
Yes, yes, graded assignment.
Yeah, I was there, or I think you haven't. Okay, okay. Now this question number 2. Okay, so question number 2, what's saying in a multiple select question? there are 4 options of which one or more can be correct. Okay, it's MSQ, that's obvious things. Let us define an event E that the option A is correct. So what is the cardinality of E? Okay, so what's the issue in this?
So, so basically it will be 2 raised to 4 minus 1, right? Number of options. So for this it will be 2 raised to 4, that is 16 minus 1. I am getting 15 as the answer. So but here it is 8. So I did not understand how it is 8.
Okay, it's not about 2 raised power 4 minus 1. It's about 2 raised power 4 minus 1. I mean, minus 1 will be within the power. Okay, I will come to this. 4 options, okay. So, suppose there will be cases like only option A is correct. Okay. See, in the question, it is asking about cardinality of event T. Okay. So, number of possible elements is what? How many possible events when only option A is correct?
4.
No, I'm asking about number of possible elements.
So 4 choose 1, that will be 4.
It's a, see, what is the question? E be the event that option A is correct. Okay. And I'm saying only option A is correct. So that is, I have one thing, right? That is, I have chosen only A. See,
Okay,
here
okay.
I'm interested in cardinality. How many things are there, right? So second option can be 2 options are correct. And see, if it's MSQ, so more than one option can be correct. First case I have taken, only option is correct. Second case I'm going to take, right? 2 options are correct. And A is one of them. It is possible or not? 2 options are correct and A is one of them. One of the 2 options, right? So what's the number of possible elements here?
Sir, A, B, A, C, like that. So you have to calculate. Sir, yes, sir. Sir, A will
So I
one.
can
One
see
will be
3
A.
C1 or not?
Yeah,
Yes,
three
yes,
choose
3
one.
choose
Yeah,
1.
yeah. Three choose one.
3 choose 1.
3 choose
Right.
1. Okay. Because A is already one of them. That means we have to choose one option out of the remaining 3, right? That means I can write in general like AB, when 2 options are correct, A is
Yes,
one
sir.
of them, right?
Yeah.
AC,
AC and AD.
AD, correct? Third case I can take 3 options are correct. And A is one of them. So what it will be?
3
3
choose
C2,
2.
sir.
3 choose 2, because A is one of them. So we have to see, we saying 3 options are correct. A is already correct. Then we have to choose the remaining 2 out of remaining 3. That means 3C2 will be 3 factorial, 2 factorial, 1 factorial. So it's a 3, right? That means I can say A, B, C, okay, and A, B, D, and what next can be A, C, D, correct? 4 option can be all options are correct. That means what?
Just one way, sir.
Just 1.
Just one?
Just one.
That means A, B,
CD.
C, D. I have one way. So what is the total number of way? 1 plus 3 plus 3 plus 1, which is 8, which is 2 raised power 3, which is 2 raised power 4 minus 1.
Yeah, I got confused. I calculated when all of them were correct. Like not just A, I included B, C, D as that also.
Okay.
So
Now it's clear?
Yeah, clear.
Yeah. Oh. Okay, so anything else? Anybody? Or if everything is clear, so close. You got the concept? So far we have discussed a lot of probability based theorems, multiplication rule, independent rule, and the graded assignment questions, everything. It's
Sir,
clear
we
for
are
everyone?
clear with everything.
Yes, sir.
Sir, 1 minute, sir.
Yes, sir.
1 minute.
Yeah, yes, please.
So this is graded assignment 7, right?
Yes, yes.
Can you show me second question?
This one?
Second question. Sir, why this is different in my like?
Yeah,
which-
it's a yeah. It's a different for everyone.
Oh, okay. Okay.
It's not yeah. It's a different for everyone.
Okay. Okay.
Yeah.
It's a
I
similar
think
one.
there.
The numbers are
Yeah,
different.
yeah. The questions are similar,
Okay.
but numbers are different for everyone. It's not same for everyone. So you have to do on it your own.
Okay. This is the first thing I come to know. Like even the question papers are different.
Yes.
Okay.
It's from week 3 onwards. Same. I mean, questions are same, concepts are same, but numbers are different for everyone. So that no one can copy. I mean, everyone have to do on its own. Okay. So anything else, or you can move ahead of now.
Thank you for the card explanation, sir. That was perfect.
Okay, okay, thanks.
So when will be the next class?
Next class, I think it's on day after tomorrow, on Tuesday, 8 to 10. It's a
It is
solve with
solve
us.
with us.
Yeah, before one day due date, before one day of due date of the graded assignments, there is solve with us session related to that. Okay.
Okay, so Tuesday will be the next open session.
No, Tuesday is
Open
solve with
session,
the
right?
session. Solve with the session.
Solve with
for-
us. Okay, okay.
Yes, solve with the session for week 8 graded assignment.
Okay, okay.
Okay. Yeah.
Yeah.
So, sir,
Okay,
it's gonna be the same, right? Like if we have anything like after, like right now, we don't have any. Like I think a lot of people will get some more doubts. So that's the only way discussion forum, right?
Yeah,
Like
discussion
before.
forum is there. Yeah, see, what is the thing? After the end of the slides, we normally try to solve your query after the
Yeah,
end
yeah,
of the
yeah.
slides. And second thing, you can post on discussion discourse. Third thing is, if you want, then we'll try to conduct an on-demand session. Okay. So you are familiar with the on-demand session, right?
Yes, sir. Yes, sir. Yes.
Yeah. So we'll try to conduct an on-demand session. Okay.
Okay, sir. Okay, okay. Thank you, sir.
Okay, then thank you, everyone.
Yes, sir.
Bye.
Thank you, sir.
Thank you for the session, sir.
Hope yeah,
Thank you,
your
sir. Thank you
doubts
so
was
much.
cleared.
Thank you,
Yes,
sir.
sir.
Okay, thanks. Bye, everyone.
Good night, sir.
Yeah, good night.
Good night.